So this is a problem from the 2015 AIME, and it asks if there are 2 to the 10 possible 10-letter strings in which each letter is either an A or a B, to find the number of such strings that do not have more than 3 adjacent letters which are identical. So if you actually tried to directly find some of these strings, right, just constructively count them, it's going to be very difficult. So instead, what we're going to try to do is observe some patterns. And in particular, what I'm thinking of is if you are given one of these 10-letter strings and you're told that, okay, it ends with an A or a B, and the letter that comes right before that is of the opposite or the opposite type, right? You have an A ending here, and then it goes the opposite direction. Well, think about the rest of the sequence that comes right before this A or this B. So this sequence is going to be 9 letters long, right? And it also has to follow the rule that none of the 3 adjacent letters are identical, right? And it's going to be completely uninfluenced by this A here or this B, right? Because it's going to be of the opposite color or the opposite letter, right? Now, this would change if we put a B here, right? And now we're told that, okay, you can't put another B here, right? Or more than 3 letters that are identical. So that means you can't put 4 B's in a row, right? But since they're of the opposite kind, this doesn't matter. So they're completely independent of the last letter, right? So you have 9 letters long and no more than 3 adjacent letters, right? So this is basically just satisfying the problem statement, but if we replace the 10 with a 9, right? So if we called, if we created a function to find the number of sequences with A or B's in them that do not have more than 3 letters which are identical, and we call that f, and we're trying to find f of 10, right? This is basically the problem. We can realize that if it ends in an A, or this is supposed to be a B, if it ends in an A or a B, then in this case, the rest of this sequence is going to be f of 9, right? Now, if we instead end with 2 A's, right, or 2B, and we say that, okay, after this point, we're only going to have a B, or we're only going to have an A, right? So now, and notice that we can say this is f of 9 because these are the total spaces of f of 9, right? We know that if we just took into consideration the one where it ended with A, right, we can only have f of 9 such that it ends in a B, right? But we counteract that by saying, okay, we're also going to look at the case where the last digit in the f of 10 sequence is going to be a B. So now f of 9 can also end in an A, right? So this is going to count the total spaces of f of 9 sequences. And the same logic will apply here as well, only this time, because we want this total to be 10, the length of this sequence is going to be 8. So this is going to be f of 8, right? And then, again, we apply this with f of 7. And notice that we can't do the same with 4 A's, right? Because, remember, we can only have 3 adjacent letters. No more are allowed. So what we find that is f of 10 equals f of 9 plus f of 8 plus f of 7. And now you might say, okay, how is this useful whatsoever? We now need to calculate all of these as well. But you know that we can apply the same relation that we just found to f of 9, 8, and 7 because nothing was actually special about our number 10, right? We could have easily applied the same logic to if we wanted the large sequence to be of length 9 or 8 or 7 or really any integer n, right? And this is going to be helpful to find the total because there are certain sequences that we can easily find the count for. Let's say f of 1, right? How many of those sequences are possible? Just 2, A or B, right? If we want f of 2, we can have AB, AA, BA, or BB, right? All the possibilities are valid. so that's 4. And f of 3 is the same, right? You just multiply it by 2 because you can have an a or a b there. 2 to the 3, so 8 here. And now we can use these to find f of 9, 8, and 7. So we know that f of 4 is going to be the sum of 3, 2, and 1, right? The three numbers that come before it. So that's going to be 14. F of 5 is going to be the sum of the three numbers that come before it. So that's going to be 26. F of 6 is going to be 48. And f of 7, now we're getting into the numbers that we care about, right? F of 7 is going to be 88. Yeah, 88. F of 8 is going to be, let's just add these up. Oops. Add the 26 later. You have 6 there, 3, and 26. You have 162 here. And now f of 9 is going to be f of 8 plus 7 plus 6 as well, right? So now that's going to be 48 plus 88 is 136 plus 162. That's 298, right? So f of 10 is now going to be the sum of all of these. So that's going to be 170 plus 80 plus 298. So 8, 5, and then 9. So 24. And 548, you just calculated f of 10 as 548. So that will be our final answer.